So today we are going to learn about aromatic hydrocarbons. Benzene and its derivatives are known as aromatic hydrocarbons. They are generally formed as CnH2n-6. The term aromatic is used because of the characteristic and often pleasant odors of these compounds. Coal tar and petroleum are the source of aromatic compounds. They are unsaturated, but they show different properties from alkenes and alkynes. For example, they give substitution reactions rather than addition. So for this part, general formula is important. General formula, if you know the molecular formula of benzene, you can figure out molecular of benzene. It is C6H6. Okay, so if it is N, it can be N, but like at the same time it can be 2N-6. Okay, so if N is 6, then 2 times 6 minus 6 is equal to 6. So this is why SCNH 2N-6, the general formula they say. Okay, and then aromatic. Aroma means nice smell. Okay, pleasant odor. Okay, so they have usually aromatic hydrocarbons. They have nice smell, pleasant odor. So this is why coal tar and petroleum, they are the sources of aromatic compounds. We get them from petroleum. Okay, fractional distillation of petroleum. Okay, remember. Okay, they are unsaturated. Okay, kind of, you know this term too. It means all bonds are not single. All bonds are not single. You have double, and if you have double and triple bonds, remember, double and triple bonds between carbon atoms, they are unsaturated, and they give addition reaction. It means you can add hydrogen or you can add halogens, remember. But if all bonds are what? If all bonds are single, okay, at that time they are saturated, we say, and they give substitution reaction. But you expect them to give addition reaction because they are unsaturated. They are doing the reverse and kind of they are giving substitution reactions. Okay. Benzene and water insoluble boiling at 80 degrees Celsius has the molecular formula of C6H6. It has very stable structure. Kekuler proposed the first reasonable structure for benzene. The 6 carbon atoms are located at the corners of regular hexagon, and hydrogen atoms bond to each carbon. Carbon atoms have sp2 hybrid orbitals, and carbon-carbon bond length is 1.39 angstrom. Here, water insolubility is kind of, because it's hydrocarbon, they are nonpolar, so this is why they are water insoluble. Okay, here. So it has a very stable structure because of the is because of the bonding. Okay, the type of bonding present in the benzene ring. Okay, this is the name of the guy who proposed the first reasonable structure, Kekuler. Okay, so let's draw one and see what the structure bonding in benzene ring. Okay, we have 6 carbon atoms. Okay, 1, let's say 2, okay, 3, 4, and we have 5, 6. Okay, so and each one has one hydrogen. Okay, I'll just put hydrogen around. So this is going to be structure. Okay, and then you have double, single bond, alternate. You have 4 sticks to remember. Okay, double, single, double, single, double. Okay, and you can even change their places. If you change their places, kind of is going to be, they usually use a circle to show it. Okay, I mean, like you can put here to double, it can be single, double. Okay, kind of, let's see, it can be single here, double, and single. So this is why usually they, in place of instead of just doing something like this, they put a circle there. Okay, kind of, they put something like this. It means there are 3 double bonds all around. Okay, so, and this carbon atom is sp2 hybridized. Okay, sp2, remember the bond angle is going to be 120, and then what else, the bond length between 2 carbon atoms is 1.39 angstrom. Angstrom is going to be 10 to the minus 10 meter. Okay, remember. Okay, angstrom. And then it's not double bond, because double bond is 1.34. It's not single bond, it's 1.54. So it's something in between, 1.39. It's kind of weird, eh? So what else? Okay, and here you have the structure, molecular structure for benzene. Okay, so remember you have carbon atoms at the corners and each one has one hydrogen. You can draw two shape structure for benzene, so this is why they put a circle here. Okay, so this is a typical benzene structural formula. Okay, why are they so important? Because the aromatic hydrocarbons, aromatic compounds, usually they have stable, they have very stable structure. So it is why they play a role in stability of the structures of some biomolecules. Okay, like even in DNA, RNA. Okay, so of course they are a bit different, but they have this the same bonding there. And then we use benzene and some derivatives of benzene as solvent. Okay, solvent. Remember, organic solvents. Okay, and then and usually we use them to make some medicine. Okay, the starting they are starting compounds, starting aromatic, starting molecules to make other molecules. Okay, so it's good for us. It's good for us. Um, so it's very important compound. Okay, that's it.